Hello everyone. Today I'll be talking about Retrieval-Augmented Generation or RAG. It is one of the very well-known applications of LLMs, and it is getting used in all sort of agentic framework, or there are different applications. So Uber is using it for optimizing its human interruption, and there are all sort of application of it. So we will first check how we can actually build a simple RAG to get the answer after the document, and then over the period of time, if we get chance, then we will see how we can check the performance of the existing solution, what are the steps we can actually evaluate what it is performing, and then how we can actually evaluate the performance of this solution, and then maybe we can check if we can actually integrate it in some sort of agentic framework. So that's my overall plan is, but today let's see what is RAG. So before that, I hope you have access to some of the LLM. If you don't have, then maybe you can use Olama to deploy the models. So you can go to this Olama website, olama.com, download this application and deploy the model. So it supports deploying various models. You can actually deploy the model with the least weight. So currently I am using Llama 3.1 8 billion model, and I'm actually able to deploy it in my MacBook itself. You can check which model works for you, or if you don't have enough space, then maybe you can use some of the credits from OpenAI or Claude or some any other solution provider. Um, but yeah, I'm relying on you to deploy the model. After that, so once you have deployed the model, so actually what exactly is RAG and why it is useful. So I will go over this architecture sometime later, but let's see this scenario. So let's say I have this created this virtual world called Cross. Now this is actually a magical planet which LLM is not aware of, because I created this document. To this completely magical world, there are lots of magical creatures. People can use magic. There are lots of hidden mysteries about this place. So this kind of place, this Cross is. But actually LLM is not aware of this. So that's where actually this REC kind of solution helps it. So this can actually help LLM provide this context, and then they can answer this context. So this is actually a very simple example. um, I have this file, you can read about it, but I will just go over how actually it works. So first, maybe you can install these dependencies. These are needed to run this application. So what I did is I created this chat olama object. So this is from LangChain. Ideally, you should be able to replace it with any other um, provider. You can use it as chat, OpenAI, or anything like that. And then I have created this invoke method, so I can directly actually call this invoke method over the prompt. And I asked a simple question like why you will love exploring Cross. And now actually let's run it. So since I have already installed those dependencies, I will directly run this. And yeah, so we got the response, and if you will see the responses, you will see it appears you are interested in exploring Cross, but unfortunately the LLM is not aware of a specific location called Cross. Could you be thinking of Kahorong? It suggested some other place which actually not we are talking about, and that is because it is not aware of the context. um, Now let's see how actually our RAG solution will help here, and what exactly is RAG and how actually it helps the overall framework. So I will just open this diagram. This is actually taken from one of the LangChain's course. Since I am relying on, I'm using LangChain, so I thought why not keep it. So basically, what we do is we have this documented cross.txt. So we need to actually provide this information to LLM somehow. So one thing we can do is we can actually directly give all this information to LLM directly and start question answering. But then there are multiple situations arise when document is too long, or there are multiple documents, there are multiple source of documents, and sometimes usually LLM is context of from 32,000 to 128,000. There are some other models as well, but that can be expensive as well. So we'll consider we have like a small model which has context length of 32,000. So in that case, actually, we won't be able to provide entire document to LLM directly. So what we do is we actually split those document. So we can use different techniques depending on how we want to do it. So maybe we can count the number of characters. So let's say if there are 100 characters, then use those 100 character and create different documents of size 100 characters. Then it can be based on words, it can be based on tokens. So there are various ways we can split the document. So first task is we will split the document. So now initially we had few documents. Now we have actually splitted those documents into smaller documents, and we will have fixed criteria. So let's say the maximum length of document is 500 characters. So that's where we will get the splits. Now we have splits, so we will actually convert this into a semantic space of vector embeddings. So what are these? So basically, it's easier. Computer actually understands the numbers better than the characters. So that's why we create embeddings. So there are various ways to create embeddings, and actually how we reach to embeddings. So maybe I can talk about it sometime later. But for now, you can assume like there is a separate model called embedding model. You can give that text to those embedding model, and it will generate array of numbers. So basically, for every split or every sub document, we will have array, right? So at this point, we will have multiple arrays of numbers, which actually are is tied with the documents. Now we will actually store this in vector store. Now vector store is actually a database which stores these numbers along with our original text. And there are multiple vector store. Milvus is one of the vector store. Elasticsearch is one of the vector store. In our example, we will be using Chroma, which is also in-memory vector store. There is FISS from or Face from Meta. So there are multiple vector stores. Some of them are paid, like Pinecone is paid one. So, but yeah, for now we will use Chroma. So we can store this embedding in vector store. And actually, I will provide code for all of them, but that's how we will store it. Now we have all the documents stored in one of the database. Now what we'll do is um, our our database is ready for query. So whenever user asks some of the questions, we will actually take that question and pass it to embedding model. For now, we will consider it is same embedding model as the one we are using here for document size. Although it is not necessary, it should have same dimension. But yeah, for now we will say these both are same embedding model, and we will get some embedding for this query. Now we will see which all documents are similar to our query, and we will ask vector that this is the vector of my current query, and give me some of the vectors which are actually similar to my existing query. So it will return us some of the document. We can have some limit, like we can say give me 10 documents, give me 100 document, give me 4 document, give me 1 document. So in that way we will have some of the documents. Now at this point what we will have is we will have a query, question, and the relevant document which can contain our potential solution or answer. Now we will combine this both of this information and send this to LLM and say, yeah, this is the actually query, and these are actually the context where my answer will be, and just give me the solution. So we will just say LLM that, and then LLM will give us answer, and that's actually the entire flow of reg. There is nothing fancy happening here. Now actually let's implement this in step by step. So what I am doing is, so I am actually using LangChain. LangChain has actually provided a library for lots of the work that we want to do, but it's actually very easy to implement this by our own as well. Maybe at some point of time we can dig into that as well, but for now we will use LangChain because it's easier to get started there. So I am using this text loader, which basically will do is load the file and then give us the document. So we will do loader.load, and it has actually loaded these documents here. Right, now we have document here. Now, like I mentioned, there was this step of splitting, right? So we are using this recursive character splitter. So it does actually nothing. It just divide the document in based on number of characters. So here I have set the chunk sizes 500. Basically what it will do is it will take 500 documents, sorry, 500 characters, and take a cut here. And what this overlap does is basically from first document it will overlap with previous 50 characters. So that's how this will work. Now it has actually created object of this recursive character text splitter, and now we are actually going to split the document. So we have provided this document which we have loaded and created the split out of it. So here actually we will get array of documents, and then this is the embedding model. So like I mentioned, right, we will be using this embedding model to generate these arrays. So we are using this sentence transformer model, which is actually very common model and freely available. So I'm trying to keep everything open source and open source. I'm trying to use open source model so that we don't need to rely on any provider. So yeah, that's how I can actually load the embedding model. So this will download the embedding model from Hugging Face, and then this vector store. So this vector store is the database where actually we are storing the embeddings as well as document. So I have actually this from document API is from LangChain. So actually this will help us easily replace the vector store. So that's why I'm using this LangChain vector store. So here actually I have created this object of chroma.from documents, and I will provide these splits which are actually all the splitted documents that we have, the embedding model that we are using, and the path. So basically this will create the embeddings of this will actually store the embeddings and the text out here, right? Now that we have actually done all that, this will actually store the data in vector store. Now it's time to retrieve the data. So that's what we will do. We will retrieve the data. This is just to showcase, so I will maybe let me actually skip this part for now and run the other part. Right, so now you can see like we have created all these vector store, and so if you want to see, I can actually show you what it will look like. So maybe split of 0. So this is what actually split of 0 look like. This is actually a document which has metadata which will have source, file name, and page content will be the content of the file. So that's how it is stored. So this is one of the split, and there are multiple splits, so you can check there are 11 splits here. Now actually since we have already done that, let's try to retrieve the document and check if this works. So we are creating the retriever. So retriever is basically retrieving the data from vector store. Let's do that. So retriever is configured. Now let's run the retrieval. So these are actually 3 queries: extraordinary creatures of crows, where is the capital of crows, and name the guardian who protects the wood. And then I will just run it. So, and how retriever work is basically we can call this get11 document method on retriever, and this will give us relevant document. So that's what actually is happening. Here actually I am just printing the document and its source to show how it is working. And let me actually comment this to not get it very crowded. And yeah, so here actually you can see how it runs very fast, and we got actually the context from here. Now since we are actually able to configure the retriever part, let's begin our main part where we are using building the RAG. So I have created a simple prompt where I am saying you are a helpful assistant and you only provide the context, use only the provided context to answer the user question, and if the answer is not in the context, say I don't know, and keep the response short and precise. So that's how actually I have created this prompt. I have provided the context here. Context will be the one which I will be getting from retriever. LLM will be the one Olama model which actually I initiated in the beginning of this lecture, And this str parser basically is to show that we are actually printing this output. So that's why, so there are multiple parsers available, and this is basically text output, and str output parser is one provided by LangChain to just display the content, or um, yeah, directly print and directly use the content, right? So now we are actually created this prompt template. So this is actually nothing, it just says that these are the variable I have in the prompt that I have created, and I will be passing those values. So that's how I have created it, and then I have created the chain. So what chain does is, initially it will use prompt, basically this information, and then provide this prompt to this Olama model. So basically all this prompt will be sent to our LLM, and then once we get the response, it will just print this response, right? So now here actually I have asked this question, why you will love exploring cross, and then I have just did retriever.invoke to get the relevant document, and I have updated this variable with question and query, and then I will simply do invoke. So yeah, it says whether your dream of exploring ancient ruins, learning powerful spells, or meeting fantastic creatures, Cross invites you to imagine impossible. So that's what our document is about. It Cross is a magical place, right? So, and now let's say if I ask something out of this context and see how it works actually. So why you will love exploring, maybe say Mumbai. Now since it is not part of Mumbai, so actually it should not answer and say I don't know. Let's see how actually this works. So now it says I don't know. So that's how it is supposed to be. It should not answer the knowledge it is not aware of. You can make it answer, but ideally in React solution you only want to answer it the information that you have provided. Now since we have this solution, maybe sometime later we can actually think about how we can actually evaluate the performance of this solution, maybe identify one of the data set, or maybe we can directly move towards improving the performance. So I will think about what will be better and then work on that. Thanks for watching.